first and foremost, I wanted to say, thank you and apologies for me not being able to be there in person due to some family issues. And so, what could possibly go wrong with this technology, right? Yeah. So here we go. Really, this is a tremendous opportunity for me to speak to you, a group that I normally don't speak to, and hopefully I can present to you kind of some grand challenges here regarding space and this idea of space traffic. So I'm going to share some slides with you, and I'm sure it's all going to work out quite nicely, and we'll just see how this goes. All right. So here we go. Let's advance the slides here. Yeah, so the research program that I have here at UT Austin really focuses on three major areas, the larger circles. We focus on information sources, and you can think of these as sensor measurements from things like radars and telescopes, and also human-based information, tweets, semantic type stuff, things that you could find on the internet. And we're really interested in as much information as we can gather about stuff in space. So the other area that we really focus on is system behavior, and we're looking at sensor systems and then the actual systems that are on space, whether they're satellites that are actually working or pieces of space junk. And I'm going to describe to you what I mean by space junk here in a little bit. And then the last area of research, it's like, okay, so there's stuff in space and there's stuff that we are observing, so what? And that part is the knowledge extraction, quantification, and assessment. So those are the three areas of research activity. But if you had to ask me, all right, dude, so like, what do you actually do? I would say those are the smaller circles. So we're really in the business of developing models about all these things that we can give back to the public for public good. I like to put things in terms of Venn diagrams because it's simple for me to understand that way. And I want you to think about all the set of all events and processes that are actually occurring in space. That's the large circle. And for a variety of reasons, that entire set of events and processes is unknown. We can't know everything, it turns out. I know, surprise to many folks in the crowd, I'm sure. And out of the set of all the stuff that's happening, there's a subset of things that we measure, which I'm going to call evidence. And then we have a subset of things that we call beliefs or hypotheses. And if we're really lucky, the stuff that we believe or hypothesize coincides with stuff that we measure. And I'm going to call that inferred knowledge. So one of the things I tell my students is, if you want to know something, you have to measure it. And if you want to understand something, you have to be able to predict it. I would probably say, and some of you might think I'm joking, but several times a month, I get people that are emailing me about the flat Earth, okay? And so what I tell them is, if the Earth is actually flat, your hypothesis has to explain all past observations, and it has to be able to predict the future. And so far, they haven't been able to demonstrate that to me. So in an ideal world here, we'd love for all these three circles to coincide exactly, but they don't. And so that's part of our problem. There's stuff that's happening in space that we just don't know, we don't understand. All right. To give you some more context here, it turns out that White House signed this thing called Space Policy Directive number 3. And I'm not going to read the whole thing to you, but just to say that there are all these capabilities that we depend on in space, like position, navigation, timing, location services, banking. A lot of satellites now route banking information. Weather warnings you've seen with hurricane and typhoons, getting these warnings ahead of time. And soon, even the internet itself is going to be a space-based service. And so nothing is really protecting any of these services from any harm, from loss, disruption, or degradation. And so national space policy is saying, hey, we really depend on space. We need to do something about being able to monitor all of that space and hopefully come up with a set of space traffic rules that all of us can abide by, because as it turns out, we don't have any space traffic rules to date, as wild as that may seem. So in this next chart, to give you a better idea of kind of what we're talking about, NASA has an orbital debris program office at Johnson Space Center in Houston, where they've put together a couple of plots. The one that you see to your left that shows something that looks like it's growing, unfortunately, that is the number of tracked objects since we started launching things since Sputnik. And right now, we currently track about 26,000 objects, ranging in size from your cell phone all the way up to the space station. And some satellites are like school bus size. But we don't track anything really smaller than that. And unfortunately, we believe that there are probably about 500,000 objects that could harm a satellite that go all the way down in size to a speck of paint. And so, unfortunately, a speck of paint moving at the right speed that collides against something that works could actually render it useless. And so that's part of this tragedy that we face in space, this orbital iceberg of sorts. The next slide here is really painting a little bleak of a picture, in the sense that we have a couple of people that want to provide global internet with satellites, and they plan on launching lots of stuff in the next 5 or so years. So I told you that we track a total of 26,000 objects. What I didn't tell you is that currently, out of the 26,000 objects, only about 2,500 are things that work, and everything else is garbage. And we actually plan on launching about 10 to 15,000 satellites within the next 5 years or so. And this gives you an idea of the number of satellites, the company, the altitude, and what year, okay? So we're gonna see this a little bit better here. Here you can see kind of the clusters of where they wanna put these objects based on their altitude. So number of satellites versus orbital altitude. And when these things overlap each other, that's definitely something we need to be concerned about. So things that enable space traffic management, we really want space to be transparent. So we want to know where everything's at and where everything will be, hopefully. And we'd like to stimulate that with people being able to talk to each other. We need to be culturally competent, because it turns out different cultures manifest themselves differently in space in terms of behavior. For instance, if you wanted to know when U.S. satellites maneuver their satellites, whenever they change orbits, Americans usually do that on Tuesdays, Wednesdays, and Thursdays, because weekends and holidays, we don't like to work on those days. And you don't want to do a maneuver on a Friday, because Murphy's Law says that sometimes bad things happen and things don't work out right. So you don't want to stay at work late. And you certainly don't want to have to think about doing this when you first come back from your weekend. But that's American culture. But not all cultures behave the same way. And we really need to get a better handle on the physics of what's going on in space. So, essential ingredients for space traffic. We need an independent way to monitor stuff. I think maybe some people in the room maybe heard that India blew up one of their own satellites earlier in the year, and this created a bunch of debris, and some of that debris is still on orbit. And people from India say, you know, the Jedi mind trick, those aren't the droids you're looking for, sort of thing. All that debris is going to come back within 45 days, except that there are other people that say, no, in fact, there's a lot of debris that's going to be up there for decades. So who do you believe? I don't have the evidence to infer that on my own. People in the room probably don't have that evidence. And so there needs to be an independent way to keep people honest and monitor this stuff, okay? We need to have sustainability metrics. We need to develop best practices and standards. So back to one of the things that I said earlier, you can't manage what you don't know, and you don't know what you don't measure. People want to know what normal behavior is in space. People want to attribute cause to an anomaly. If my satellite stops working, was it because the sun had a hiccup and there was extra energy that upset the electronics? Or was it Jimmy, who really can't stand me and did something to schwack me when I wasn't looking? It's very difficult to figure that out because space is not ubiquitously and persistently monitored, and not everybody is sharing information. So that's part of this idea of wanting to crowdsource information if possible. To make things a little bit worse, there is here's real data from a telescope called the Space Surveillance Telescope. It's currently in Australia, and all the dots that you see are detections that the telescope is made on a single night, one single night's worth of detecting stuff. So the good news about the Space Surveillance Telescope is that it detects lots of stuff. And the bad news about the Space Surveillance Telescope is that it detects lots of stuff. So all the dots that you see that are black are things that were detected that we believe we know what they are. And every dot up there that's not black is basically a UFO. We have no idea what that is. That's, you know, St. Louis, we have a problem. And so, you know, which one of the non-black dots is something that could be a hazard, that could harm you? Yeah, so this is one of the things that kind of keeps me up at night, is figuring this out, this background clutter. So this is part of the challenge I'm posing to you. We'll get to exactly what it is I'm going to request from you here soon. We talk about detecting and tracking. Some people try to use those words interchangeably. I'm just going to say this. Just detecting isn't good enough. You have to be able to track. Tracking means detecting and uniquely identifying. You want to do both. You want to detect stuff and know its identity. And so if somebody says, well, really, show me the difference. Okay, there it is. That's the difference between detecting stuff and tracking stuff. The stuff that's tracked is black, and the stuff that is just detected isn't. And so another way to say that is, imagine if we had a bucket of detections. We have some sensor that detects stuff at 3 different times. Most of the stuff up there doesn't report its identity. So how do we solve that identity crisis? How do we combine information, manage it, exploit it, do big data science analytics, that sort of stuff, maybe apply some machine learning AI to try to reverse engineer what the identity of all these things in space are? That's part of the problem. Ideally, what we'd love to do is start from way on the left with the thing that we measure. These are all different things that we can measure. And we'd like to move towards the right to say, what combination of things that we measure gives me insight into physical properties of these objects? What combination of those physical properties gives me insight into functional properties and operational properties? And then even further to the right, can I then classify these objects into different species and maybe even get to, you know, a one-to-one kind of identity? That's what I'd love to be able to do. I'd love for you folks to help me do that. So this is going to be a bit busy. Certainly, the people that are way, way up on top, cover your left eye and no, I'm just joking. So we use these things called ontologies or schema. And what we'd like to be able to do is using graph databases, kind of superimpose these schema and ontologies on the graph database to make this into a knowledge graph where we can then semantically link all these different parts of participants and contributors to what's going on in the space domain so that we can discover some stuff, because we need to be in that business of discovering. And so one of the things that we've done here is we have a three-tiered kind of process. We have instance data, different sources of information, which I'll actually show you what I'm talking about here in a little bit, from the United States Department of Defense, from Russia, from some commercial satellite operators. So all that stuff comes into our landing zone. And then we have interpreters that know how to map the information in each one of those sources into this graph database. Currently, we're using Neo4j as our graph database. So maps it into these this ontological framework. And then we have apps that can query that graph database and do a variety of neat things. So what I'm about to show you, I have this ASTRIAGraph loaded on the next screen next to me that I'm going to actually give you a walkthrough and kind of disclose more of these problems to you to get you guys to weigh in on, hopefully. So, you know, get you to think about a little bit more. All right. So what are the goals that we have? Well, you know, we want to make space transparent and predictable because we have more and more participants on orbit. Bad things can happen, and it's very difficult to even attribute, you know, cause to any of these things. Basically, given any body of evidence that we currently have, unfortunately, multiple hypotheses explain the same evidence. And these can be very different from each other. Everything from, like I said, Jimmy schwacked me on purpose, to the sun had a hiccup of energy and that upset my electronics. And your courses of action really depend on the cause of this anomaly. We have these space traffic needs in the sense that what we put on orbit isn't randomly scattered, and I'll show you that. We have highways, and these highways have no traffic rules. None. And so pretty much you get on orbit and you kind of do whatever you want and just hope for the best. And we got more and more stuff on these space highways. And so again, we've developed this kind of ontology-based knowledge graph that we'd love your help with and try to find ways to try to solve that problem. So here we go. So what I'm going to do is I'm going to kind of skip over some of these slides. I'm going to put that one up there before I switch over just because I love that quote. And let's see if I can go over here and share this with you. If you can see a planet that kind of, and a lot of dots rotating, I want to hear some noise in the crowd. Okay, so this is, you know, this is ASTRIAGraph kind of visualized, and what you're going to see here is we're looking down on the Earth, and these are about half a dozen or so different sources of information that we bring in to this graph database, and when you go to the website, it just brings up the orbits. But this outer ring that you see is the geostationary ring, and it's one of the highways I was speaking about. And it turns out that if you put a satellite at that orbital altitude, it takes that satellite about 24 hours to go around once, which, as you know, it coincides with an Earth day. And so it's the perfect place to put communication satellite because it kind of stays over a specific longitude of the Earth, and that way you can point your satellite TV dish and leave it alone and always get a signal. But unfortunately, there are a lot of dots that you see here, and only the ones that are in orange are things that work and everything else is garbage. One of the things that you can see is this pink string of pearls, and all of these objects in that string of pearls were generated from one object that blew up very recently in the past few weeks. So all that string, all these dots right here come from a same parent object, unfortunately. One of the other things that you can see is you can see kind of a pattern here, and all those came from the same parent object, and you can see another pattern over here that also came from the same object. So within the last 12 months, we've had 3 rocket bodies blow up that have generated a significant amount of garbage that now we have to try to avoid and track. So what else is the problem, you would ask? Well, we don't all agree on where things are located. So I'm going to give you an example here. Let's see. Here's an example of some object. It's a Planet Lab satellite. It's in low Earth orbit. And you can see a couple of dots. You can see a number 1. And I'm going to pause this really quick. Let's see if I can pause this. Maybe I can't pause it. Hold on. Yeah, here we go. All right. So number 1 is where the United States Department of Defense believes that satellite is located right now. Number 2 is where the owner believes it's located. And number 3 is where a commercial radar company believes it's located. Those things don't match up with each other entirely. So one of the questions is why not? And so there's different assumptions that we have on the physics. There's different assumptions that we have on the measurements themselves. There are many assumptions that we have, and they don't all agree. And so, you know, it's not just the number of objects up there, it's the fact that we don't even have a consistent picture of exactly where it's at. Here's another example with another Planet Lab CubeSat, Flock 3P8. And so, again, number 1 is where the Department of Defense says it's located. Number 2 is where the owner says it's located. Number 3 is where Leo Labs, the commercial radar company, says it's located. And number 4 is where I believe it's located. Yeah, I'm not going to lie to you. I'm not perfect. But it's just very interesting. Okay? And so this is a problem that we have as well. How do we bring in heterogeneous data, heterogeneous information? Some of it is sensor information, some of it is semantic, some of it's opinions, some of it's tweets. How do we bring all that stuff into a common framework and make sense out of it to get a realistic picture of what's on orbit? You know, if somebody were to ask you, how do you know that you have the world's most accurate clock? Your answer might be, well, because I have hundreds of them. And you would actually be right. Because that's how we tell time on the Earth. We have hundreds of atomic clocks, cesium fountains, rubidium, that sort of thing. Each clock has an opinion of the time. And then what you do is you gather all of these opinions and look for the centroid of them. The weighted combination of these things gives you what the timing standard is. So how do we come to a weighted combination of opinions of stuff on orbit? And as you probably know, if you don't have enough data, it's very hard to tell that. One of the things that is the most difficult challenge that we are facing in putting together this graph database is in generating the schema and the ontologies. I mean, one challenge to people in the room might be, how do you generate ontologies autonomously? Like if I just have a bucket of disparate information, how can a computer go in there and basically read in all these things and sort out different fields and actually propose what the schema should be? Because every time somebody brings me a new source of information, I have to spend a long time with my staff to try to comb through that manually to figure out what does each field mean, what does it represent, and how do I make sense of that, comparing and contrasting against information that I get from other folks. So that's one of my major challenges. So as you can see, things look a bit bleak here. We do face a tragedy of the commons if everybody just wants to behave any which way they want. We don't have any space traffic rules, but we do have space highways, and we don't all agree on what's on orbit and where it's going and what it is or isn't. And so with that, what I'd like to do is I'd like to see if there's a possibility to kind of open this thing up for questions if people can see me.
So, and the question is whether there's any plan for collecting the microspace garbage. Did you hear that?
Yes, absolutely. So I think that's an excellent question. I will say that you're not the first in line to try to make money to collect space garbage. And one of the things that we need to do is we need to be able to find a way to make that something that you could monetize. And in order for us to do that, one of the things that we're working on is we're trying to develop what I'm calling a space traffic footprint. And the space traffic footprint is an analog to a carbon footprint, as the name kind of suggests. And certainly we're not going to measure space traffic in terms of tons of CO2, but we have to come up with another metric for that. And you can think of the space traffic footprint as the burden that any given object poses on the safety and sustainability of anything else. So an example would be when I get into my car, as soon as I start backing up from the driveway, I'm a burden to all other pedestrians and all other drivers. The fact that I exist means that somebody else has to take my existence into account for their own safety. And so I would want to be able to ascribe that to every object in space, some footprint, some non-zero footprint of its burden on everything else, because you have to account for it. And once we have that, then maybe we could actually put bounties on specific objects. Hey, 10,000 shekels for removing this object because it has the largest footprint, or clean that up and I'll pay you this much. Or even insurance companies. There is such a thing as satellite insurance. They don't make a whole lot of money now, but boy, it would certainly be nice if they could now underwrite their premiums based on something like a space traffic footprint. So that needs to be created first in order for you to make your money. So I'm working on it.
So the question is, the example where things were far apart, how far apart was that? It was like miles or inches or feet or what? Well, how far was that?
Well, if I told you millimeters, would you believe that? Yeah, so we're probably looking at the largest distances between things. You're probably looking at hundreds of meters to probably a couple of kilometers.
Yep. So the question was, you twice mentioned tweets as a way to track stuff. How does that relate?
Yeah, so this is where things get tricky. So as it turns out, before things launch, sometimes you might get a tweet that says, "Hey, you know, we have Ukraine. Ukraine has this satellite. They're going to launch in 2 weeks. This so and so has a set of binoculars, and they saw some bright light in the sky at such and such time." So humans actually have some information that can relate to helping you detect, track, and even identify objects in space if you can find a way to link these sources of information together.
So the question is, how much can amateur equipment help as a data source?
So glad that you asked that. So actually, I'm going to try this one more time here, and you're going to.
We got it.
All right. So this are all information from amateur astronomers on space objects, and it doesn't show up in anybody else's database. And one of the reasons for that is because, hold on. Let's see if we can, one of the reasons for that is because a lot of the data that they provide are on supposed spy satellites. So these amateur telescope people love to try to track spy satellites, and so each one of these is supposedly something that somebody doesn't want you to know about. So I think that's kind of cool.
So the question is, what mechanisms do you have for dealing with malicious or inaccurate information?
Yeah. So this is where more data are better. The more independent sources of information that I have, the more difficult it is for something to corrupt the system, because it won't be consistent. And so I'm not at the point yet where it's easy for me to say with high confidence I can't be spoofed, but I'm going in that direction, and it's exactly why I'm trying to crowdsource independent sources of information, as many as possible, so that I can look for things that are inconsistent.
How does the privatization of space help or hinder your work?
I'm sorry, can you ask the question again?
Yes. How does the privatization of space help or hinder your work?
Oh, I want it to be as commercial as possible, to be honest with you. I want space commerce to thrive. It doesn't hurt me whatsoever. And in fact, there are more and more private organizations interested in the research that I'm doing. And one day, hopefully, we'll see some space tourism. I don't want to do it, but I'll let you go first.
All right. Right here in front. So the question is whether there's a movement to regulate with treaties or anything like that.
Yeah, so it turns out that the United Nations has an Office of Outer Space Activities in Vienna, and in UN-USA, there is the Committee on Peaceful Uses of Outer Space, or COPUOS, and I've actually been on the US delegation to the UN several times and participated in meetings where the outcome has been an adopted set of 21 guidelines that, if implemented, would definitely help in terms of long-term sustainability of the environment. Those guidelines are not legally binding in and of themselves, but if every country that signed to that, about 90 plus countries by consensus signed to that, if each country that signed to that actually implements that as space law in their own country and then try to regulate it that way, that would be quite helpful. And so that's the thing that I'm really trying to motivate, is for all these countries to now pass that as their own national legislative framework, so that we could see a more sustainable space environment.
All right, let's take one more. One here in front. So the question is, what would the recovery window for an object be, like from meters or kilometers or something like that?
The recovery window, I don't even know what that means.
So the question is, how good of a track do you need to be able to recover an object?
Yeah. So here's the thing, right? I mean, maybe at first you just need to know where something is to within several hundred meters, but then if you're going to actually rendezvous with this thing to do some sort of proximity operation or actually grapple it, you probably need to know where that object is relative to you, to below a meter, to probably like a foot or even less than that.
Okay, I think that's it for questions. Do you want to wrap up at all, or?
Yeah, so here's the thing that I want to say, right, is first and foremost, I want to thank you for even trying this thing out with me, and I'm glad that it worked as well as it did, knock on wood. But I don't speak to folks such as yourselves routinely, and hopefully I've been able to plant some seeds of curiosity and some challenges that we face in terms of being able to harness all these different sources of information, ways to organize, curate this stuff, think of methods of being able to exploit the information. And the thing is, if we don't figure out this independent way to monitor space, we could very much face this tragedy of the commons where some portions of space become unusable because of collisions and just the gross number of objects that are going to exist in any given orbital regime. And so we need an independent way to do this. And if we just wait for governments to do it, it's not going to happen. No single company is going to burden this on their own shoulders. So we need folks such as yourselves to work with me and trying to solve this stuff. And I thank you very much.
Everyone here is very appreciative, and it was a great talk. Thank you.